Vocabulary, Algebra Triumphs 1.2. Today's vocabulary, place value, inequality, negative number, positive number. Place value is a value given to a digit by its position on the number line. Digit is important to know. The number 32 has 2 digits. 3 is a digit. It has the value of 30 in this number. It's in the tens place. 2 is a digit. It has a value of 2 because it's in the ones place. The value of each digit before and after the decimal point matters. A 2 before the decimal point is going to be bigger than a 2 after the decimal point. You may have seen a number chart before. This tells you your place values. We can quickly go over some. Find your decimal point. The number right before your decimal point is your ones. Know that number. The number after it is your tenths. T-H-S at the end, tenths. The number before the 5 is your tens place. Next you have your hundredths, T-H-S, followed by your hundreds before. Keep going, you have your thousandths, T-H-S, and your thousands before it. If you struggle with place value, then this is the website you would like to go to. It is available on your start page for this assignment. More practice can be gotten to here. Inequality. A number sentence that compares two unequal expressions. It uses 4 different symbols. Less than or equal to. Greater than or equal to. Less than, greater than, not equal to. Statements are always read from left to right. Let's look at an example. This symbol means less than. We could say 3 is less than 4. That would be true. We read it from left to right. Let's look at our next symbol. This symbol means greater than. Reading left to right, 3 is greater than 2. Our next symbol. This means less than or equal to. One of 2 things is going to be true. So let's look at an example. 3 and 4, 4 and 4. 3 is less than or equal to 4. First thing we check. Is it less than? Yes, then this works. It is not equal to. Is 4 less than 4? No, it's not. Is 4 equal to 4? Yes, it is. So this one also works. You are either less than or equal to. This symbol means greater than or equal to. -3 is greater than or equal to -5. -4 is greater than or equal to -4. Is this true? Is -3 greater than -5? If you're not sure, let's check a number line. We're going to plot our number line. I have -3, -5. Numbers on the right are bigger. Numbers on the left are smaller. 3 is on the right. So 3 is greater than negative 5. Negative 3. Remember that negative. Finally, our last one, negative 4. Is negative 4 greater than negative 4? No. Is it equal to? Yes. So both of these statements have the correct symbol. Finally, not equal to. We use this one with negative 3 is not equal to positive 3. Simple as that. Our next vocabulary is a negative number. You've talked about these before. It's simply a number less than 0 or a number 0 is greater than. Go up to your number line. All of these numbers to the left of 0 are negative. Why? Because they are less than 0. 0, on the other hand, is bigger than all negative numbers. Why? Because 0 is greater than negative numbers. Positive numbers. A number greater than 0 or a number less than, or that 0 is less than. Okay, a number greater than 0 or a number that 0 is less than. Go back up to your number line. A number greater than 0. So that means I need to be to the right. All these numbers are greater than 0. X is greater than 0. Or 0 has to be less than it. 0 is to the left, so 0 then must be less than X. More numbers. Integers. Integers are very important. They are whole numbers. Remember, that means 0, 1, 2, 3, and so on. The set that contains all those. And their opposites. So the opposites would be negative 3, negative 2, negative 1. Altogether, the integers are the set from negative infinity. That's what these dots mean. The set from negative infinity down to negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way on to infinity. Negative 4 is an integer. Negative 5 is an integer. 0 is an integer. 167 is an integer. 1/2 is not an integer. Steps for using a number line to determine place values for integers. 1. Draw a number line. Okay, I can draw a number line. Bloop. 2. Place values at least your numbers and 0 on the line. Numbers on the left are less than numbers on the right. Numbers on the right are greater than numbers on the left. That's pretty easy. Next, you're going to complete the statement. Because blank is to the blank of my number, it is the blank number. Finally, write an inequality. This negative one, hey, it's your computer screwing up again. We're going to ignore it. So let's do an example. Let's use the numbers negative 5 and 167. So here's 0. What do I know? Well, I know that negative 5 is over here and 167 is way over here. Okay, I drew my number line. I placed my values and zeros on the number line. Let's look. Which number's on the left? Negative 5 is on the left, so it must be smaller than the number on the right. If I don't like looking smaller but I want to look bigger, I can simply say, let's look at the number on the right. 167 is on the right, so it is greater than negative 5. We're going to complete our sentence. Because negative 5 is to the left of 167, it is the smaller number. So I can write an inequality. Negative 5 is less than 167. Let's do it backwards. Because 167 is to the right of negative 5, it is the bigger number. So 167 is greater than negative 5. Comparing numbers using place value. Place value. If you don't know them, go practice them. Go to that lesson and learn it. First, locate the decimal in each number. Line up the numbers by decimal. Begin on the left and compare digits by place value. Complete the statement. The blank place, blah, 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 are all the same. Compare the digits in the first place value that is not the same, and complete your statement. The digits in the blanks place are not the same. The digits blank in blank is bigger, so blank is greater. We'll see an example here in a second. Then write your inequality. So I'm going to write up two numbers. All right, first thing I need to do is locate my decimals and line them up. Step 1 and 2. Then I'm going to start on the left. What place values do I have? I have my thousands, hundreds, tens, ones, tenths, hundredths, thousandths. So it says compare the digits in the first place value. Do I have the same thing here? No, I don't. So I can tell you which one's bigger. This bottom one is. I have no digits that are the same. So what does that mean? The digit 1 in the thousands is bigger. So 1267.531 is greater. Write your inequality. 1267.531 is greater than 267.542. We'll do another example. $367 comparing to 367.4. First, locate your decimal. This one, it's easy. It's right there. I have no decimal here. If you can't find your decimal, then locate your ones place. Your decimal is hidden right after it. There is my decimal. Now we need to line up our numbers. 367 point. Here's my point, 367.4. Start comparing. Hundreds place is the same. Tens place is the same. Ones place is the same. Tenths, THS, is not. So, the digits in the hundreds, tens, ones are all the same. The digits in the tenths are different. So the digit 4 in the tenths is bigger. So our number 367.4 is greater. 367.4 is greater than 367. One more. Two 201.04. 201.05. Let's put zeros on the end of each of those. Can you figure it out? I lined them up by decimal. If you can already see which one is bigger, we can complete our statement. Hundreds is the same. Tens is the same. Ones is the same. Tenths, hundreds. Oh, I have a difference. So the hundreds, tens, ones, and tenths are all the same, but the digits in the hundredths are different. So the digit 5 in the tenths is bigger, so our number 201.050 is greater. 201.050 is greater than 201.040. How to tell if a number in word form is a decimal or not? Well, let's look. Look or listen for the ending. If it has THS, it's a decimal. If it has S, it's a whole number. Tens versus tenths. The whole number is tens. Hundreds versus hundredths. The THS right here, that tells you it's a decimal. Ones versus once, this is important. There is never a once. We only ever have one ones place. Finally, 1000s versus 1000ths. Decimal, whole number. You'll often see a chart like this. Please pause the video and copy down this chart. You will use it to practice how to write a decimal number. There's only one ones place. There is only one ones place. Everything else has a THS that matches. Everything on the left ends in S. Where are S's? Let's do them in green. Our S's are here. Those are whole numbers. Everything to the right ends in THS. You can tell THS right here on each of those. These all end in S. The numbers at the top are our grouping number. We have our ones group, thousands, millions, billions, trillions, thousands, millions, billions. Decimal place value numbers follow the same pattern as whole place value numbers. If I have a 2 here, that is worth 200 thousandths. A 2 here is 200. This would be 200. This would be 2 out of 100,000. Finally, take a picture of your notes page with the place value chart. Go to the website below. The link is in your instructions page. Play a round. We're going to change this. I want you to play 3. Play 3 rounds. If it is hard for you, go to the help website in your instructions page. Take a screenshot of your final score and submit it to me. And if it doesn't show you a final score, click the 4th round and screenshot. I'll take that too. You will upload 2 pictures from your homework. Both will be submitted in the same assignment. They will be submitted to this lesson.